early afternoon. So for those of you who are entering our little room, this is the CCTST Ethics, Regulatory Knowledge and Support Care panel discussion, and we're going to be focusing on biases within AI, and you are in the right place if that is the topic you were hoping to tackle. We are letting people sort of cycle out of meeting one and cycle into this talk. So we will be getting started here in just a moment. All right, so I know that a number of other people will be cycling on, but I think that because this is a very exciting topic and it is one of great importance, and I want to make sure that both our panelists have an opportunity to engage us in a very interesting conversation and give them plenty of time to do that, along with plenty of time for questions. I think we're going to go ahead and get started. So before I introduce our speakers for today, I definitely want to make sure I give a couple of housewarming tips. Or house welcoming tips, sorry. One would be when you have some questions, as you very well might have questions during this talk, please feel free to place them in the chat. We're going to hold questions and answers to the end of the talk, and we will make sure we hit as many as possible in the order that we receive them. However, we want to also allow our two speakers to have plenty of time to go through their presentation smoothly. All right. All right, before I introduce them, I will introduce myself. My name is Jareen Meinsinder. I am one of the co-directors of the Center for Clinical and Translational Science and Training. I also am an epidemiologist at Cincinnati Children's Hospital Medical Center, and I have a very big personal interest in the topic of bias within AI. And so I'm very excited about this panel, and I'm very excited about our two speakers. We're going to start with Dr. Annu Prabhakar, who is a professor in the School of Information Technology in the CECH. Her primary research areas are computer-human interaction, health informatics, and science and technology studies. Her research focuses on designing interactive technologies for wellness and education. She also investigates the effects of technology on society. She is the founding faculty advisor of the Women in Technology organization at UC and is a strong advocate for equity and inclusion. She co-chairs Faculty Senate ad hoc committees on race and equity and is a recipient of the UC George Barbour's Award for Excellence in Student-Faculty Relations. Josette Riep is the Executive Director of Software Development in IT at UC. She holds a master's degree in information technology and is currently pursuing a PhD in IT. Ms. Riep has worked in the field of software development for over 20 years, and her current responsibilities include leadership over custom development initiatives spanning education, research, patient care, and administration, as well as equity and inclusion sponsorship activities with an emphasis on increasing STEM representation for African Americans and other underrepresented groups. Through participation in UC's diversity initiatives, Ms. Riep continues to pursue opportunities and technologies that ensure UC creates an environment that does not tolerate but embraces our differences, and thus empowers individuals and organizations to excel. And with that, I am going to turn over the reins to Dr. Prabhakar.
All right, let me bring up my presentation. Just a minute. Can everybody see the presentation?
Yes, ma'am.
All right, let me just get started. All right, thank you, Jareen. And as Jareen mentioned, I am a professor in the School of IT. And I'm very happy to be here and thankful for all of you to join. I have only 25 minutes, so let me get started. The purpose of my presentation is to create awareness of some of the challenges we face in AI, especially in the areas of diversity, equity, and inclusion. As administrators, developers, and users of AI, we all need to get well-versed in such matters. And you might ask why? Because AI-enabled systems are everywhere. We use it in our daily life, the systems such as Google search, navigation systems, or Alexa. Beyond that, law enforcement uses AI to decide who should be profiled as criminals. Marketers use AI to decide who will buy what product and at what price. And hospitals are using AI to decide which patients get treated. Banks are using it to decide who gets the loans. Universities are deciding, using AI to decide who will get admission to their programs, and employers are using AI to decide who gets hired. So previous studies have shown that in all these areas that I mentioned, there is evidence of biases in the system or the AI-enabled systems they are using. So AI provides a lot of benefits, but along with the good, there are some negative consequences. The more we understand how the AI system works, the better equipped we are to recognize those biases and, if possible, to mitigate those. I know some of you are experts in AI and some of you are not. So for the benefit of the wider audience and to make some of the examples that I'm going to use more digestible, I'm going to start with some foundational concepts of AI, some of the nuts and bolts of AI. So if you are looking for definition of AI, you would see a lot of different definition based on the context, which is very good. John McCarthy, who is considered as the father of artificial intelligence, coined the term artificial intelligence in 1956. He defined AI as the science and engineering of making intelligent machines. So intelligence, that is very important. And if you look at dictionary, Merriam-Webster defines AI as the capability of a machine to imitate intelligent human behavior. And some simply say that it's statistics on steroids. Yeah, we can agree with that sometimes. All right. So I don't know, if some of you are psychologists, but I came to know that, usually psychologists characterize human intelligence by a combination of many diverse abilities. So research in AI researchers also focus on some of the components of intelligence. It includes learning, problem solving, using language, reasoning, and perception. So let me focus on learning. First of all, how we all learn, human beings learn. I'm going to use a very simplified version of it. Suppose a child sees a dog for the first time. Some of the adult will tell the child that's a dog. And the child might kind of retain some information about the dog. And maybe next time when she saw, another dog in the neighborhood, maybe the parents say, oh, that's a dog. So she has another data point and, maybe another dog. So eventually the child will be able to recognize that pattern, how does a dog look like? And, keep that in the memory and then use it when, say, if she goes to the park and she sees another dog, she can say that, hey, it's a dog. So, but suppose the child is only exposed to dogs, and then if she encounters a deer, she wouldn't know what it is. She would be confused, or she can still think that, it's a dog. So there are issues, like that. So, so let's think about how the AI or the algorithms learn to do, prediction or classification, which are like some of the main categories of, AI processes. So let's look at predictive algorithm. What happens is historical data, is fed into predictive algorithm, usually mathematical models, and the algorithm learns from the patterns and repetitions. And the people who are developing this, they will test how accurate the predictions are, how better they calculate the classification. And after testing different models, they would select the one which is many like a criteria for selection, accuracy, whatnot. So the historical data is what is teaching these algorithms how to predict, how to classify, and things like that. Just like we are teaching that child how to recognize a dog. Okay. So once the designers or developers decide, okay, this is the mathematical model that is giving me the highest accuracy in prediction, maybe the false positive, false negative, or there are different criteria, then they test the system using a subset of the data they collected, and they make sure that the predictions and classifications are correct. So when they deploy the model in the real world as part of a system that you are using, when a new data comes in, it knows what to do. It can predict, it can classify. Just like when the child sees that new dog, it knows exactly what it is, and it can give you the correct correct example of it. So I'm going to just briefly talk about some of the terminologies that you use here usually, and then some people are confused about it. What is AI? Is machine learning AI, or are these the same? Are those the same? So machine learning and deep learning, they are subsets of artificial intelligence. Machine learning is the practice of teaching algorithms to make decisions based on past data using mainly statistical algorithms. And deep learning is usually using artificial neural networks to solve complex problems. And it discovers patterns and it detects features too. So, maybe you can think of deep learning as kind of an advanced version of machine learning also. So just to expand a little on that, the difference, a very simplified version of it. So if you are trying to teach a algorithm, mathematical model, how to classify different vehicles or whatnot, the humans, there is human intervention in terms of feature extraction. That means the humans will say that, the color, not the color, the how many wheels, all the attributes with the values would be fed into it. So based on that, and also it will label which data point is a label, which data point is not label, which data point is a van or something like that. So it can classify and learn. But for the deep learning, you are not providing the classification or labels. The deep learning algorithms do the feature extraction and classify them. So if you have a bunch of attributes for different types of input fed into deep learning algorithms, it will cluster them into car or in van and things like that. So these type of things are used for video and audio kind of classifications in that area. So just to give you a practical example, let me bring up one of my research. This was about predicting postpartum depression. We wanted to use or augment the traditional, postpartum depression, instruments with some of the, demographic information also. So of course, we collect data through surveys, and of course, we have to convert that to the data, the numbers that can be fed into the algorithm. And so this is the data set for that particular project. So you can see that, different attributes, which are not, these are not randomly selected. These are based on research, which would have higher chance, based on risk factors for postpartum depression. The one thing I want to focus, notice is that here you can see we are classifying it. We are labeling the data when you feed. So in this particular one, this person didn't have postpartum depression. This had, the one had the postpartum depression. So the models that we feed this data into, they find the patterns and they learn it. And once you deploy that into real world, you would see that it would, it can predict. And of course, we have to train different models and, come up with the one with the better accuracy and whatnot. Okay, let me bring this up. Okay, so data set, the training set is very, very important. An AI model is only as good as the example we use to train it, or the training set. And in data science or computer science, there is a saying that garbage in, garbage out. That means if you give bad data, the algorithm will output bad data or bad classification or prediction. So the data can be incomplete, incorrect, missing, or biased. I don't have time to go into all these aspects of it. But, if for exclusion, if the child didn't learn about other kind of animal, she may not know how to predict it or classify. So let's talk about some of the biases in facial recognition. This is Joy Bulavini. She was a graduate student at MIT. So when she was using a facial recognition software for her project, she encountered a problem. That is that the software is not recognizing her face. When she put a white mask over her face, it could detect that. So I hope you kind of got the idea of what the problem is. The problem is when they trained this algorithm, they didn't have the data points of people like Joy, whose skin colors are, different features are different. So you can see that when you exclude data, that means incomplete or biased data, the software system failed. And it was very common in the early times of AI because the people usually go collect data from people like themselves. Usually they have used their friends or family or maybe coworkers, their the skin tones and images for training that system. So that can really have that it's like that girl is trying to recognize the cat if she doesn't have that information. So there are a lot of cases of biases in AI. Wells Fargo has to settle a case on their mortgage algorithm bias. Of course, Amazon, it's a famous case. AI recruiting tool, they excluded women. Why? Because they didn't have data on women being hired. For example, in the beginning of the company, they had a lot of white males as the employees. So the algorithm thought, that's what they should recommend. That's who they should recommend. So you can see that how it plays in everywhere. And then there is a really scary consequence, say, like in biases in predictive policing, and cities around the country are using it. For example, in Broward County, Florida, they are using something called Compass, a predictive model. So Compass falsely flagged Black individuals as likely to reoffend at double the rate of false predictions for white individuals. It has a lot of implications for people and families. So biases in education. Recently, UT Austin has to ditch one of their PhD program admission algorithm because, of course, you guessed it, it didn't have a lot of data, previous data about, diverse population, so that's another one. Another very important thing that we have to remember is, of course, all these biases are in the data. Then, people in the power, you have to be mindful of, to equally apply application to different population. So unequal applications of AI is another area of concern. So, for example, look at this census data of Detroit. Okay, so these, the green areas are the place that where the Black population is living, and then the blue ones are the white population is using. And this shows a facial recognition technology for, detecting, finding out who has the criminal tendency. So if you look at this, you would see very clearly that they are employing or deploying these facial recognition system in the predominantly Black neighborhood. That means, they are under, undue surveillance, and some people may not be even recognizing that. Of course, it has a lot of consequences. It kind of perpetuates the historical racial discrimination that we all know about this country. So another thing is, for example, in medical devices, pulse oximeter, it is reported that pulse oximeter give, false results for people with darker skin. Of course, there are reasons why that is happening, but it has a lot of implications for people. For example, I came to know that if you have a reading of 88 or 89, Medicare will reimburse for oxygen at home. But if it is 90, it won't. Okay. So some of these inequalities are, it's not intentional. So that's one thing that you have to understand. This may not be intentional. There are several studies that shows that women and people of color receive less pain medication, lower, equity of care, and longer time delays for treatment. And there is another thing about, women's pain. Pain is often mischaracterized. Let me go back. Women's pain is often misattributed by doctors as psychological, resulting in women who report pain being prescribed antidepressant, when they don't have that symptoms. Or, there are studies that suggest that as many as 30 to 50% of women diagnosed with depression were misdiagnosed. Okay. So the reason I'm bringing all these, stories or all these data point is that if we are using this data to create AIs that, diagnose depression or maybe to prescribe medication, if the data is steeped in the biases, the AI can really perpetuate it. And this is another thing about the white pain medication. One of the important thing that we have to be aware of this is that the scale at which the way we can scale up all these AI-enabled system. Think about all the misinformation, all the bots that spread misinformation like wildfire. So another thing is the invisibility of this system. If I am discriminated against based on my skin color, maybe the ethnicity, maybe the accent, I may feel it. I can see it in the face. I can see it in the result. But some of these AI, the damage is not visible. In the past, it was very visible. Just to give you an example, this is a very low overpass designed by the famed New York City planner Robert Moses in the 30s and 60s. He developed or he built lots of bridges and buildings throughout New York. So he built this very low so that the buses won't go through it. The reason at that time, African-American people used buses for transportation. Only the people with resources, mainly white people, could afford cars. So they didn't want African-American people to come to the beach in the other side of this bridge. This is very visible, right? But the issue is some of the algorithms that you put in, the damage that it does to people is invisible. That is a scary thought. So it is important to talk about algorithmic fairness. Another thing is algorithmic transparency. So if my application for a loan get denied, can I ask the bank, what kind of algorithm did you use? What are the data points? What are the weight you given to my zip code or my race or things like that? So the transparency is very much important. You know that if some of the companies come and ask you, you are trying to purchase an AI-enabled system, the marketing people are very good. They can, give you all this spiel and you would fall for it. But you have to ask questions about the algorithms they use. Another thing is algorithmic accountability. If you are misdiagnosed with a, or false negative for a disease, and if I get really sick, who is accountable for it? Is it the developer? Is it the, doctor? Is it the, the company that built it? Or, you have to think about that accountability too. So the main point is we have to have diversity at the table when you are deciding on a system or when you are developing something new. Of course, you have to have decision makers, but you need to have technology experts and you have to have users too. So data inclusion matters. So, many people have to be at the table when you decide on the features of what you are designing. And also we have to make sure that it is all backed by research. So Harvard Business Review is giving some practical steps to reduce bias in AI. Leaders need to stay up to date on this fast-moving field of research. When you are deploying AI, we have to establish responsible processes that can mitigate bias, engage in fact-based conversation around potential human biases, consider humans and machine can work together to mitigate bias. We can do that. Invest more, provide more data, and take multidisciplinary approach. Another thing is invest more in diversifying the field itself. So, I know that the government is understanding how AI can be damaging, abusive. So they came up with the AI Bill of Rights recently. So there are movements in that field. So I just wanted to share this quote from Joanne Chen. And she says that AI is good at describing the world as it is today with all of its biases, but it does not know how the world should be. So, AI would give you the result based on the world as it is now with all the biases. So whatever algorithm is not at fault, algorithm just doesn't work. It is the responsibility of people who are designing to make the data without bias. So, but how should the world, how the world should exist without bias? It's all on us. Only we can change the systems and cultures and, be more inclusive so that the world that we live in is less biased, so that the data we generate are less biased. So this AI system would have a better chance of being equitable. So, this is, to end my presentation with some of the recommendation in terms of asking question when you are starting an AI project or when you are trying to, like buy an AI-enabled system. What is the source of training data? Is the data inclusive? Are you excluding some important data? Where is the research that shows your source data can predict what is being predicted or classified? What variables, attributes, input are used? What is the accuracy rate? False positive, false negative, all that. So how was the developing team? Did you think about the diversity in terms of data inclusion and other aspects? Whether there were decision makers, technology experts, and of course users. Above all, you have to incorporate user experience from beginning to the end. You have to research what the users want, and also you have to test it thoroughly. When you are deploying an AI system, you have to use your own test cases and to make sure that it is giving you the expected results that you are expecting without biases. So you can test it. So usability testing is very important. So I would stop here. So I hope you have some awareness, which I hoped about, how biases can get into AI system. So I would now stop this, and I would ask Josette to start her presentation. Thank you. Let me stop sharing. All right.
Okay. Let me know if you all can see my screen. Am I sharing?
Yes, we can.
Okay.
Yes, we can.
Okay, so I'm going to go through briefly a project that we're working on now that really looks at how we leverage AI in education. And given all of the pearls that Dr. Prabhakar talked about, we also want to talk about what some of those promises may be, but making sure that we, really pay attention to the pearls so that we don't fall into the same category that many of the AI engines unfortunately have today. And so let me start off with why. I've been at the university for a very long time, and I am grateful for the opportunities that I've had here. I also am grateful for some of the experiences that I have had that have shown me, what some of the challenges that many of us face are. And so for many years, I've really focused on how do we create opportunity for others. And I would truly believe that we have a unique opportunity to bridge the digital divide and ensure folks like Sean, who you see on the screen here, have just as much opportunity as other individuals. And so that's really the driving factor here, regardless of the mechanism or the tool. Just like Dr. Prabhakar said, AI is here, it's not going anywhere. And so I think it's up to us to figure out how to leverage it in the best way possible. And in terms of algorithmic bias, there are so many different types. And I just wanted to highlight that here to show you that when we're considering how we create tools and engines and algorithms, all of these need to be taken into consideration. Reporting bias, meaning, are we really only looking at a subset of data that kind of creates what I call negative cycles, right? So we're, for example, always looking at DFW rates, for students, does that create this negative spiral that doesn't allow us to really look at what makes students successful? And we'll talk about that a little bit here moving forward. The study that we had an opportunity to work on, and I'm going to skip through some of this, is really about how can we leverage AI ML to better understand success patterns, because I truly believe that part of the challenge that we have is that, especially in education, many of the tools like Civitas and some of the others that have implemented AI really look at fail factors, right? And so if we're only looking at fail factors and we're not thinking about what makes students successful, we're kind of creating this feedback loop that really has the opposite intended consequence, right? Just as historical information, some of the background in terms of STEM, because that's where my focus is just looking at what we already know is that the number of opportunities and jobs in STEM continues to grow at a very high rate. But the other side to that, and I think many of us know this, but I think it's always alarming when you see it, is that the overall growth in STEM is declining across many demographic areas, not just African Americans, right? But if you look at African Americans, we're looking at, some of those numbers actually going into negative. So instead of growing, we're actually decreasing in some areas. And so this is another way to look at it. As the demand is increasing in higher education, we have the challenge that those that are graduating has continually decreased. If you look at engineering and computer science in particular, you can see the large number of students that either change majors to something outside of STEM or drop out, right? And for people of color, there was a study that was done that shows that around the 3rd or 5th year, you hit what's called an invisible wall, or some students hit that wall. And so the challenge that we have is not only how do we pull more students into STEM, it's how do we make sure that they're supported in a way that they can be successful throughout their collegiate career. One more background stat that I wanted to show is just the growth rate in engineering across the board. And if you look from 2015-16 through 2019-20, you can see how the growth rate has changed. So at the time when we need more people in these areas, it's actually decreasing dramatically, right? And so what are we doing? How are we trying to address that? And how can we leverage technology in order to support that? I'm going to skip over this one because it's just more stats that I think prove the point. But I do want to point out that for many of the larger IT companies, African Americans still make up less than 5% of the IT workforce. And that's something that I'm looking at changing. And so when we're thinking about the data that we use for the algorithms, part of the challenge we have is that the historical data sometimes does not contain the full picture. And so for African Americans in STEM, I like to show this timeline because it kind of shows you, what's happened from the establishment of the first university in the United States to the first HBCU, all the way to what we're calling the innovation age, where we have all of these jobs in STEM available, right? And you can see the challenges that we've had to face, through each of these, including separate but equal, and, getting to, the civil rights movement and moving beyond that. And so a big question is, how do you take these historical factors into context when you're building these engines, right? So there's this concept of, there's reality of institutionalized racism that we need to make sure that we keep at the forefront. There's something called racial trauma. How do you incorporate that into your engine in order to make sure that you're really looking at a holistic picture? And then just based on where we are today, there are a ton of societal factors that we need to deal with. And I do not think that it does any of us any good to believe that these societal factors also aren't something that we need to take into consideration as we're both building engines and creating support structures for students. And so the research question is, how can you leverage AI in order to identify success patterns that ultimately help? In this case, I'm studying African Americans, but what you'll see is that there are many groups that would benefit from this based on their personal experiences. The myth that I like to put out there is that there's a perceived lack of interest in STEM. So maybe there's just a lack of interest in pursuing that. Maybe there's, identified gaps in skills, and that's the reason that people aren't successful. Maybe there's issues with engagement, that are contributing. These are kind of some of the theories that have been placed out there in previous research. We also have examples of things that work. We know mentoring, partnerships, internships, things of that sort. And the university obviously has a great co-op program and an internship program, which can certainly be helpful. GSU actually created a model that uses AI in order to address what's called the summer melt. So in order to ensure students successfully matriculate into college, they leveraged artificial intelligence to keep in touch with the students, to make sure that the students gained the information that they needed in a timely fashion, and adapted, based on their needs in order to meet the ultimate goal. And so we see examples of AI in different places. There's also an example that's used at the university right now in Civitas, which I think, warrants more review, where it tries to predict how successful you will be term to term, and also has a model that I don't think the university is using right now that allows you to predict whether you'll successfully graduate. Those things are interesting, but they're based on, what Dr. Prabhakar just talked about, extremely dangerous, because how are those predictions created? what makes up the data, that defines, those areas. So a lot of work to be done there. For this study, going back to the data, we wanted to make sure that we looked at a wealth of information. And so we pulled data from the National Center for Educational Statistics, and we looked at about 22,000 full responses over 6 years. So this study took students from their first year in college until graduation, and it surveyed them 3 times over 6 years. It includes students who did not graduate as well. And so that information is there for us to leverage. Just the breakdown of the data, getting back to, do you have enough information to make decisions? You'll notice that the breakdown when you're looking at the different demographics is pretty drastic, the difference, right? But there was enough data for us to at least do an initial assessment. The categories of information collected by NCES include a ton of information. The ones I highlight in red, I think, are important because sometimes we focus on, the fundamentals in terms of, what are their grades, how many math courses did they take, were they in honors? And we don't look at, what sort of relationship did they have with faculty members, what sort of support do they have from their peers at the institution, what were their expectations in terms of educational experiences. All of that information is actually housed in the study. And so we did a brief analysis of the data. We did a lot of work in preparing the data and summarizing it to make sure it was de-identified properly, created a model, and then looked at insights. It's definitely not something that we would want to use for predictions yet, but I think it sets the stage for what we need to do next. And so just jumping into some of the results very quickly, we took all of that data, identified, the question that we wanted to answer is, what are those success factors that we can identify for students? And in particular, can we create an engine that really identifies those success factors and really provides support to students in that way? And so we decided to run it against multiple models, and you can see the results here. Many of the models came back, with a very low classification error, which was great. And then if you look at the accuracy error on the flip side, obviously, you can see it this way as well. And so you can see many of the deep learning engines came back with what appears to be very good results. And if you look at it a different way, the top 3 that we decided to really focus on came back, with very low classification errors, high model accuracy errors, and we were able to, leverage it to predict whether the students, would graduate successfully, with a bachelor's degree, and you can see the percentage points there. And so a couple of things to point out, about, that is one, regardless of what engine we use, you could see commonalities, and I apologize for the busyness of the screen, but let me just explain that part of what we saw come out were common things like likelihood, expected EDU. And what that gets to is confidence, right? How confident do they feel? And what we saw is many students felt confident initially when they joined college, but as they progressed through their collegiate career, their confidence level dropped. Job intensity was another one. Students who had a full-time job obviously had more challenges, right? And just trying to get through college. But there's also the flip side of that. Those students who did not have any job were also very challenged as well. And so it's finding the right balance, leveraging, opportunities like the co-op program here at UC, work study, and some other things that may be beneficial in that area. You can see things like health that play a big role. Intensity in college, meaning were they able to continue through college at a full-time status? Faculty interactions, how they interact with faculty was very important across multiple models. And so just to kind of put a finer point on training data and how important it is, when we ran the models against all of the training data available, meaning the entire pool of 22,000 students, things like their student interactions, so their peer support, were very important, you know, whether or not they could maintain persistence, how many honors classes they had. Detractors were, you know, advising, for example, those sorts of things, which was interesting. But when you look at it strictly for African Americans as an example, the things that were most important changed, right? And this is using logistic regression in this case. So can we assume, you know, that because we're training a model against that monolithic 22,000 that has a dominant grouping in there, that that model is going to work for everyone? And I think the answer is no. We need to make sure that we're looking at it from multiple perspectives. And here is gradient boosting, just to show an example. This is what it looks like for all. This is what it looks like when you only look at the African American group. Random forest, similarly, when you look at it based on the grouping, the information changes. And so it brings up a lot of questions about how do you really design a model? How do you make sure that it's representative of the different groups? How do you make sure it's personalized to you? And how do you make sure it's intersectional, right? Meaning, you know, that yes, I'm African-American, I'm also a woman, I'm a mother, you know, all of those things come into play. And how do we make sure that we're really thinking about that as we, you know, build the models? And so we decided to move forward by really looking at random forest and thinking about some of the ways that it predicts. And the reason that I did that is because random forest creates these what's called independent trees, and that basically go through a competition based on my individual characteristics, right? And so once we did that, we were able to kind of create some scenarios where we could see how all of these things fit together. And again, I'm going to apologize for the busyness of the diagram, but let me just explain this one, for example. Faculty interactions being something that's very important, and then job intensity. If I have strong faculty interactions and I do not have a job, look at my chances of obtaining a degree. If I'm working part-time and I have positive student interactions and support from family, and I have mixed intensity, I have or full-time, then I'm more likely to graduate. This one is, you know, stops, the number of stops, right? And so if I have a high confidence level and I do not have any stops, I have some likelihood of graduating. If I have even one stop, meaning that I had to take a break in college for whatever reason, I'm much less likely to graduate. Math. This is a big one because we all believe that math is going to be important in these STEM areas, which is true. But even those who have 4 or more years, if they have one stop, look at the likelihood that they will graduate. And you can see that it's much less likely, whereas 0 stops, I'm much more likely to graduate successfully. So there are many examples like that, and I'm going to just kind of jump to conclusion and next steps. With all of that said, I think the initial study pointed out that there's ways that we can really look at these models differently in order to think about not students' risks or their failures, right, or their fail points, but the success patterns and how we can really amplify those. And so how do we use those? We use those in virtual mentoring, bias detection. So perhaps the university's using models. How can we really determine whether those models are really beneficial to the student, and how can we identify potential issues upfront? Automated matching for internships and other opportunities, enhanced skill development. All of these are things that we look forward to pursuing. In our next phase, we're actually working with the Provost Office to really look at students who are entering in their first entry-level math courses here at the university, and determining whether we can identify patterns that will help them using some of the same information. There is a lot here that we'll need to really pursue, but this kind of gives you a glimpse as to some of the challenges and the opportunities, I hope. And I will turn it back over to Jareen.
Thank you very much. I appreciate both of you and the work that you're doing. I've been writing down questions, but there are questions that are in the chat, and I want to make sure that I respect all of our attendees. So the first one, what are the intellectual property and privacy concerns regarding the historical data? I know that Deep AI and Midjourney have, for example, trained on prior artworks to which the owners did not have the rights. Much of the data mining of Google, Meta, and others has similarly sketchy origins.
Just like, many different aspects of AI, data privacy and privacy concerns are like a big issue, as you can imagine. With the historical data, as Josette mentioned, obtaining those are difficult. I know when Josette was trying to get that data, there are many layers to get to it. So there are some, I'm not sure even it's due to privacy concerns at that point, because it's all de-identified. So getting historical, if you think about, where are you trying to get the data from? Say, for example, Amazon, if they want to get their historical data, it is easy. But if you are interfacing with another entity to gain access, that can be problematic. And of course, with all the social networking platform using your data without you even knowing, that is a big issue. So I know that now, the iPhones, Apple asks whether you want to share. I don't know who would say yes, but apparently there are people who would say yes. So it's a very difficult issue that need a lot of work. And, I would say that people should be aware of it. And it's kind of a personal responsibility to safeguard your data. I hope that answers, it's a deep, a discussion that is going on, still going on.
Thank you. And on the just a comment about who would say yes. I'm gonna go out on a limb and say most people don't understand when they're agreeing to things versus when they should be denying things. And so we tend to agree to an awful lot, thinking that's just part of what we do and not realizing what's happening with the data we're agreeing to share. The next question, great presentation, Dr. Prabhakar. Please, can you elaborate on the artificial neural networks used in deep learning?
I'm trying to explain like simply in general terms. Artificial neural network kind of mimic the human brain, all the neurons, the connections we have. So one of the big thing about deep learning is that you don't have a lot of information about the data that we are feeding into. For example, it's being used for, say, like when you have a check that you want to deposit. So when you take a picture and, send it, they are using this deep learning AI to, characterize or like figure out the numbers and, alphabets. It's not clear cut as, machine learning, data needs to feed the machine learning, where you can have the attributes can be measured and you can have the value for that. But in the cases where you just cannot provide that, like image processing and things like that, or video processing, then the system itself learns, or system itself classify that. It's called feature extraction. It find out what is used for describing something. So that is the ANN, basically mimicking human brain function through mathematical model. All right, I hope it's.
Thank you. This is a comment, and I believe this came after during Josette's talk, that folks do not realize that empowerment of any disadvantaged community only empowers all, and the opposite is also seen. Interesting findings, Josette. Any ideas why no job posed a challenge as well for students studied?
Yeah, that's a great question. And my hypothesis is one thing, and I'm going to share that. And then we're looking deeper into the data to see if that's true. But I think that students who actually work part-time on campus and in the field that they're actually studying are much more likely to be successful. So that part-time employment, I think, represents that versus students who are working full-time because they have to pay the bills, right? And so they're trying to struggle just to, to do that. Students who do not participate in positions that are in their field of study, for example, at all, I think are less likely to be successful because they're not getting those reinforcements in that actual experience, if that makes sense. And so that's something we're looking to prove through the data, but that's my hypothesis right now.
Thank you. Also, I am intrigued by how stops affect the rates of college completion.
Yeah, this one, I've shared this in a few different presentations, and usually the people I share it with are like, yes, that makes sense. And I'll just speak from my own personal experience. I had to stop going to college for a period of time because I had to work, I had to pay the bills. And so it's very hard to kind of get back in and get into the swing of things at that point, right? And so I think even one stop makes a huge difference. So the other thing that I didn't share that appears to make a big difference, at least with this study, is whether you live on campus or not, right? So if you're able to actually experience and engage in the collegiate environment and you have residents on campus, that seems to create more opportunity for success. And so things like the new Marion Spencer Scholarship, I think, are a great example of, hopefully seeing that come to fruition for many students.
Thank you. Thanks for your presentation. It's so informative. I'm interested in how AI can assist more inclusive recruitment of patients in clinical research and how it can assist to decrease health disparities in care and research. You make very good points about the need to ensure transparency, fairness, and accountability, and this can do much to build trust in the community for both areas.
So of course, for data inclusion, it is very important, especially in the health area, to have diverse representation in the data point. And I know it's very difficult to have representation. So I would say that diversifying the group is the first thing that we have to do. So usually, as I mentioned, we all have biases. We all have prejudices. So we like to kind of recruit from, people who we have easy access to. So in terms of recruiting, there are many layers to it. If the people who are designing this AI system, if they understand how important, collecting data from diverse, participants is important, they will put the money for that, increased, financial commitment is really needed in data inclusion. And then, the awareness of the importance of data inclusion for, betterment of society or maybe less biased society is very much important. So if you say empower or make the people, the leaders, aware of the need to diversify the team is very much important. And also maybe empowering the participants, or maybe telling the people, if we don't volunteer, the system may not be fair to us. So maybe just to put some, I don't know how we accomplish it, but, I'm pretty sure we can come up with the ways to do that, communities in community settings. So those are some of the things that I'm kind of thinking, now.
Thank you. And as a follow-up, in 2 weeks, there will be another panel that is actually focused on the impact mitigation in research and healthcare. So focusing on AI bias in that very same arena. So some of those questions that you may have around healthcare may be addressed in that particular session as well. And we are coming to the end of this panel. And I really appreciate both Annu and Josette taking their time to educate us all about AI and the importance of considering bias in AI and mitigation strategies. I want to also say that I really appreciate Josette's framework for looking to predict the positive and not the negative, because that is exactly what we always do, is predict the negative, and predicting the negative tends to perpetuate the bias that we have in the way we think. So I appreciate you framing everything that you do in the positive. That's very, very, very powerful. And with that, I am going to say adieu and thank you very much for spending the hour with us.
Thank you.